I'm going to show a quick example here of how to program in an algebra equation, including the question, solution, and worked out solution. Right now I have it just as a fixed equation that will never change. It'll just be 2x plus 8 equal to 10. So if I were to actually solve this by subtracting 8 from both sides, I'd get 2x is equal to 2. Divide both sides by 2, I would always get x is equal to 1. So down here, programmed in solution, I've just got 1. That's all that would ever happen. That's not very exciting. And then I've got the steps that I described down here in the worked out solution. So if I hit check answer over here, it's going to give that worked out with those steps and the correct answer of 1 here. So to make it a little more exciting, on this side, instead of a 2, I'm going to bring in a random variable a. Instead of an 8, I'm going to bring in a random variable b. And instead of a 10, I'm going to make that my random variable c. And I know, because I'm a teacher and I know division by 0 is going to be bad, I want to make sure that a is not ever going to be equal to 0. So up here in the top, I've got checked a is not equal to 0. And a's values can be anywhere from -5 up through 10. So if I wanted to stick those just to positive values for right now, I could do that. B and C here. And then let's say I want to make sure that I'm not going to get 0 for either of those other ones. I'm going to check these two here. So then I'd go down here. If I hit test code, right now I haven't updated my solution, so it's always going to just have that static here, and that would not be true for this case. So I've got to update that down here as well. So changing my steps here, I'm going to be subtracting b instead of subtracting 8 from both sides. So this became an a, this was a b, and this was a c. And now I'm going to be subtracting b from both sides. So I have plus b and then minus b, and then I have my c value here minus my b value. So I'm doing this symbolically on this side, and then this should be an a now instead of a 2. And when I have my plus b and my minus b, those are going to simplify out to just be 0. And then c minus b is where this number is going to come from here. So in those braces, I'm going to put c minus b. And then over here, I'm still going to have my a. And now I'm going to be dividing both sides. Instead of by 2, I'm going to divide both sides by a. So here's that place where making sure a is not equal to 0 is important. So I have a, and then divided by a. And then this part came from c minus b. And then this part again is my a that I was dividing both sides by. So then I would get 1x still, so that's not going to change. And then this is going to be equal to c minus b. And I'm going to need to do that quantity, so I'm going to do parentheses here. Divided by a will be my overall answer. And then up here, I can take that and I can paste that in as the new solution. And I don't need my square brackets up here. It's just going to do the math with that part. Square brackets are just going to be when you're trying to mix in text and variable values. So now if I hit test, I get some new values here. I check my answer, so it's going to take that equation and solve it symbolically. And this is going to get a little confusing. We've got some ways of working with coefficient functions here to make that simplified out a little bit. But we can see that this is going to give us the correct answer, and I've got this mess right here. So I could also have my answer as a fraction instead. So if I wanted to do my reduce function here, I'm going to have c minus b as the numerator and a as the denominator. And I'm going to also use that down here so it's not quite so messy. I'm going to put that in angle brackets on this one. So now in this one it would have been a nice integer value anyway, but we'll see some other ones here where we get a fraction So here's a case where we'd have a fraction coming up, and instead of dividing it out, it's just going to leave it as a simplified negative 1/9 value. So that's kind of a quick synopsis. You can get into some more details using coefficients and those functions to kind of rewrite addition as, or subtraction as adding the opposite, and things like that would make this kind of stuff here showing up simplify out a little nicer for you too. Hope that helps as a visual of one example. If I wanted to export this code and save that in a bigger set, I would hit get code here.